We're going to do section 3.4.3. We're going to do 1 and 2 and perhaps 3 and 4 here. So we're going to start off with an open box is to be made out of a 10-inch by 18-inch piece of cardboard by cutting squares of equal size from the four corners and then bending the sides up. Find the dimensions of the resulting box that has the largest volume. So the cardboard is going to be 10 inches by 18 inches. And we're going to cut squares out of the corners. So they're all equal size, the four corners, and then bending up the flap that's sticking out here. This is gone because we're cutting it out, and cutting it out, and cutting it out. And we're going to fold up there, fold this flap up, fold this flap up, and fold this flap up, and make a box. Find the dimensions of the resulting box that has the largest volume. Well, this box's volume is going to depend on how big we cut the squares out. The bigger we cut it, the less width there'll be, and the less length there'll be, but the higher it'll be. So these are squares, so I'm going to call the amount that we cut out x by x, each one of them. So then, if this length is 10, the width of the bottom is going to be all of the 10 minus x on this side and minus x on this, so it's going to be 10 minus 2x. And the length is going to be 18 minus an x on this side and minus x on that, so it's going to be 18 minus 2x. And the height is going to be folded up this x, so the height is x. So the volume is going to be 10 minus 2x times 18 minus 2x times x. Now, in this form, it's a little tricky to do the derivative because we'd have to use the product rule to find the derivative of this times this plus the derivative of this times these. Now, if I just multiply this out, it'll be a much easier derivative to take. And of course, if we're trying to maximize something, we set the first derivative equal to 0. Because if the first derivative is equal to 0, we're either at a max or at a min. So, 10 times 18, 180. 10 times negative 2x, negative 20x. Negative 2x times 18, negative 36x. 2x times 2x is 4x squared. Both of those were negative, so that comes out positive. And then this is all times x, so I've got 180x. I've got 56x times an x, so it's negative 56x squared plus 4x squared times x is 4x to the third. So the volume is equal to this expression, and so the derivative of the volume with respect to x is 180 minus 112x squared plus 112x, 2 times this, 1 less power 1, and 3 times 4, there's 12x squared. Now there's probably something that goes into all these. I think 12 goes into that. See, 12 go into that? Not really. But easiest way to find out how to make that be 0, to set it equal to 0, is to just graph it. And so I've got 180 minus 112x plus 12x squared. I could use the quadratic formula also, and then I can go graph, and I get a 0 right there. Let's see if I can put this someplace where you can see it. So I can go second, calculate the 0. That's between 1 and 3. Between 1 and 3, and it's about 2, and it says that's 2.0632. 2.0632 is the critical number. I have in my calculator program quadratic formula, and I could have put in A as 12 and B as negative 112 and C as 180, and one of the answers is 7.27 and one is 2.06, which I just had 3.2 on the graph. And the other one, if I wanted to see the other one, I'd have to look over here further. So I'd go to the window and say, look further over, like maybe out to 8 in the X. And then if I push graph, there's one and there's the other. Right there, 7 point something, 7.27. But we got to think about what's doable. Can you fold 7 inches up on this side and 7 inches up on this side if it's only 10 across? I think the biggest square you could cut out would be a 5, and it wouldn't have any width for left because 10 is 5 plus 5. So the answer has to be smaller than 5. And so this answer is nonsensical, and this is the value of x. So what's the dimensions of the bottom? Well, that will be 10 minus 2 of those by 18 minus 2 of those. So if I want to get that, so I can quit, let's see. I think my x, when I found that in the thing, nope. Second, calculate the 0 between 1 and 3, and it's about 2, and it says that. So now x is this. Second, quit, x, enter. See how x is that now? So that makes it easy to do this. So 2x is this, and 10 minus 2x is 5.8734, blah, 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 35. And the 18 minus 2x is 13.873. That's the bottom, and the height is what x was, the 2.0632. Okay, number 2. Rectangular storage container with an open top, so there's no top to this, is to have a volume of 26 cubic meters. So the volume has to be 26 meters cubed. The length of the base is twice the width. So if this is W, the width, this is 2W, the length. The material for the base costs $11 per square meter. Well, the base is going to be W by 2W. So that's 2W squared. That's how many square meters is the base. And each of those square meters cost $11. So there's the cost for the material for the bottom of this. The material of the sides costs $9 per square meter, and we got to find the area of the sides. Well, there's a height that we haven't figured out yet, but it would be H times W for this end, and H times W for the end over here. So I've got 2H times W's. That's times 9. And then I also have $9 times this side, which is H times 2W. H times 2W is this side, and the side over there is also the same, so I got 2 of those. So far I have 22W squared plus, so this is 4HW, and this is 2HW. So I got 6HW times 9, and 6 times 9 is 54. Well, I'm getting forgotten here. Yeah. So I got 54 HWs plus this, and that's going to be not the volume, but the cost. Well, I want to take the derivative so I can minimize the cost, so set the derivative equal to 0, finds max or min, but I got 2 variables. It's not a cost as a function of just one. But there was a constraint. The volume has to be 26. So the volume of this box is width times length times height. And that's got to be 26. So 2W squared times the height is 26. So the height must be, dividing by the 2W squared, it must be 13 over W squared. So I can replace this H with this 13 over W squared, so I get the cost is equal to 22W squared plus 54 times 13 over W squared times W. So this W would cancel one of those W's, and I have 22W squared plus, let's see, 54 times 13. Is 702. 702, and that leaves a W in the denominator, which I'm going to put as to the -1 for taking the derivative. So this is the cost, now a function of just one variable, W. So to take the derivative, it would be 44W plus -1 times this, so it would be -702 w to the minus 2, which means w squared in the denominator. And we're setting this equal to 0. So if that's going to be 0, that means that we're going to have, I'm going to multiply this, and this by w squared. W squared times this would be 44w to the third. I'm multiplying this whole side by w squared. Minus 702 equals, and that times w squared is 0. So now I add 702 to both sides and divide by 44, and I get w cubed equals 702 over 44. And then I take the cube root, and I get w equals the cube root of 702 over 44. Cube root is to the 1 divided by 3 power. And I get 2.517. I'm going to store that in x. So now this calculator knows that's what x is. So what w is? We got 2.517, blah, 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 some extra numbers. That's the width. And this would be in meters, because they gave the problem, this was all in meters up here. So now, what did they ask for? Well, they asked for the total cost. So to get the total cost, well, that was here. And I want to use this for the w. So since I've stored the w in x, I should be able to, let's slide this over so that's a better view there. I should be able to just type this in with x in those places. 22x squared plus 702x to the negative 1. Enter, and I get a total cost of $418.28. $418.28. Okay, let's go to number 3. It says, maximize the area contained by a fence. An ostrich farmer wants to enclose a rectangular area and divide it into 6 pens with fencing parallel to one side of the rectangle. See the figure down here, where there are 620 feet of fencing available. To complete the job, what is the largest possible area of the 6 pens? So that's all of them. So I'm going to do it the way one of our students said in class. They said, well, what if I call this x and this whole thing y? So that the area is x times y. Now I could have put y on each one of these, and then this whole length would be 6y. I usually prefer to do that, but a student did it the other way, so let's go ahead and do it this way. So now we have 620 feet of fencing, and it has to make 1, 2, 3, 4, 5, 6, 7 x pieces. It's got to go this length, that's x, 7 times, and it's got to go y, if I use y for the full one, twice, and that is the 620 feet. This is my constraint equation. I'd like to take maximize the area, and it would be taking the derivative of this and setting it equal to 0, but it's got 2 variables, so I want to get it to be 1 variable. And I think I'm going to go for x, which means I want to get the y out. So I'm going to solve for y in here. So y would equal 620 minus 7x divided by the 2. So I subtract the 7x and then divide everything by 2, which is 310 minus 3.5x, if you will. That's what y is. So now the area as a function of a single variable, x, is going to be x times 310 minus 3.5x. Multiply by x. So that's the area formula, and that's easy. We could take the derivative here, but we'd have to use the product rule. Here it's just a power rule, and the derivative as a function of x is 310 minus 7x. 2 times 3.5 is 7x. And we set the derivative equal to 0 to find the max or mins. In this case, hopefully it'll be a max. So if I add 7x and divide by 7, I get x equals 310 divided by 7. And this would be feet. In decimal, 310 divided by 7 is, that looks like 44 and 1/7? 2/7. 44 and 2/7. Let's see. Minus 44, math, change it to fraction, 44 and 2/7. So that's the length of each one of these. If I took that times 3.5 and subtracted from 310, I know the length of the whole pen. So I'm going to do that. I'm going to do 310 minus 3.5 times 44 plus 2/7. And it says the y is 155. And if I divided that by 1, 2, 3, 4, 5, 6, I'd know the width of each individual pen. But they wanted the largest area, so that'd be 155 times the 44 and 2/7. 44 plus 2/7. Oop, 7s. 6,864.29. This would be feet squared for area. Okay, this one's a little confusing, as I remember. The top and bottom margins of a poster are 8 centimeters. And the side margins are 6 centimeters. The area of the printed material of the poster is got to be 388 centimeters squared. So that's just this part. Find the dimensions of the poster with the smallest area. Okay. So the area of the full poster is going to be, well, let's see, we don't know what this is, so I'm going to just call this X. And I'll call this here, I don't know what this is either, I'll call it Y. And the area would be X plus 16 times Y plus 6 and 6 plus 12. That's the area. So I've got 2. But there's 2 variables in this. And so I need to get the area as a function of 1 variable. And so the area of the poster itself, X times Y, is supposed to be 388 centimeters squared. So if I solved for Y, it would be 388 over X. If I solve for X, it'd be 388 over Y, and I could replace either one. I'll go to make this function of X only, and that would be X plus 16 times Y, 388 over X plus 12. Now, I could use the product rule to find the derivative of this, but it might be easier to multiply this out. X times 388 over X is just 388. X times 12 is 12X. 16 times this is 6208 over X, and 16 times 12 is 192, and that's A of X. So then I'll take the derivative of this, because I want A prime, and I'm going to set the derivative equal to 0. So the derivative of 388 is 0. The derivative of 12x is 12. This is 6208x to the minus 1. So this becomes minus 6208x to the minus 2, or x squared in the denominator. And the derivative of 192 is 0. So there's the derivative. And I'm setting this equal to 0. And to get the x squared out of the denominator, I'll multiply everything by x squared, and I'll get 12x squared minus 6208 x squared times this cancels the x squared in the denominator, and x squared times this side is still 0. So I get 12x squared equals 6208 divided by 12, and I get x squared equals, let's go. Divided by 12, and I get 517 and a third. And then I need to take the square root. And I don't think I'll need the negative one. It would be plus or minus, but the negative for this length here would not make any sense. So I'm going to take the square root, and I get 22.745. and that would be centimeters. For the x, and then the y would be 388 divided by that answer. 388 divided by the answer I just got, and that would be 17.058. So the width would be 17.058, and the height, centimeters, and the height would be 22.445 centimeters. Okay.